Good afternoon. My name is Komang Damarjaya. I am representing my other research team member, Dr. Sudirman and Dr. Wayan Sudika, in presenting a paper titled Mung bean cover crops improve soil organic carbon and maize yield in a semi-arid area. We are from Faculty of Agriculture, University of Mataram, and currently I am based in Dryland Resource Management Study Program, Postgraduate, University of Mataram. To begin with, let me introduce the structure of the presentation. First, I would like to start with introduction, followed by material and method, then result and discussion, ended by conclusion and suggestion and acknowledgement. First is introduction. The maize productivity in Nusa Tenggara Barat in 2018 actually higher than the national productivity. We produce 6.71 ton per hectare, while the average national only 5.24 ton per hectare. We grew hybrid maize in semi-arid area, and the hybrid could produce up to 7.4 ton per hectare at population density up to 100,000 plants per hectare. To produce 7.4 ton per hectare of maize, the sunlight captured by maize crop at tasseling should be around 95%. And then that crop requires very high fertilizer, like 600 kilogram per hectare of NPK Ponska and 300 kilogram of urea. And that's why this practice is considered expensive by the farmers, and from our point of view, this practice has negative effect to environment because of the very high inorganic fertilizer use. And luckily, the maize farmers in semi-arid area usually they grow mung bean along with the maize. We saw the opportunity in here to use mung bean as a strategy to reduce the use of inorganic fertilizer in the long run. How? Is by using mung bean as cover crops. Some theories earlier already shows that cover crop can improve nitrogen and organic matter in soil. Cover crop can reduce nitrate leaching from maize plantation by 40%. Cover crop improve soil structure, improve water holding capacity, and increase nitrogen fertilizer effectivity. And our research earlier also shows that mung bean provide additional income to maize farmers. But the use of mung bean as cover crop in maize plantation rarely reported. That's why the aim of this study is to study soil organic carbon and maize yield improvement under mung bean cover crop treatment with different population density and desiccation time. Material and method. The experiment was conducted in semi-arid area of Gumatar village, Kayangan, North Lombok, in April to September 2019. And then the soil properties in here, as you can see in here, is very poor. The organic carbon only 1.2%. Also the nitrogen, phosphate, and potassium is very low. And the soil structure was sandy loam. The treatment, we have 6 treatment with 1 control. We have 250,000 plant of mung bean that as cover crop per hectare up to 500,000 plant per hectare, and desiccated at 2 different times after planting, 28 and 35 days after planting. The treatment were replicated 3 times, and all the treatment were arranged in randomized block design. The mung bean varieties used was FIMA 1, was planted following maize crop in the previous rainy season. Each plot size was 350 times 500 centimeters, and the cover crop desiccated with a mix of paraquat and glyphosate. Before desiccation, cover crop biomass was determined. Maize varieties used was NK212 produced by Syngenta and were planted in double row pattern at 2 weeks after desiccation time. Parameter measured at maize synthesis was plant height, number of leaf, light interception by maize canopy, plant tissue analysis for N, P, and K, as well as soil organic carbon, while parameter measured at harvest was maize yield and its component. These are two pictures. The first one is early establishment of maize, and this during the maturing stage. The results show that the biomass of cover crop increased with the increase of population density as well as with desiccation time, and that's resulted in the improvement of soil organic carbon because there was measured before desiccation, and this was measured at 60 days after maize growth, that this already degraded and affected the soil organic carbon and improved soil organic carbon with the improvement of population density and desiccation time, as well as the total nitrogen, total phosphate, and total potassium in the leaf tissue improved with the higher population density of cover crops. In terms of plant growth, the plant height was not affected by the cover crops treatment, but number of leaves slightly affected by the higher population density of cover crops, and the light interception by the canopy was significantly improved with the increase of cover crop population densities. For yield, the cob weight and weight of kernel per plot increased significantly, especially at the higher population density of cover crops, as well as the weight of 1,000 kernel. That shows the quality of the seeds improved with the increase of the population densities because of the improvement of soil organic carbon in the soil and the NPK in the leaf tissue. That also resulted in the improvement of the maize biomass at harvest per plot. Based on this result, we can conclude that the mung bean cover crop improves soil organic carbon and maize yield by 60%. That's the increase of soil organic carbon at the 500,000 plant of cover crop per hectare compared to control treatment, and 24% yield of maize improvement compared to the control treatment. And the highest mung bean population density with later desiccation time, the 35 days after planting, produced the highest biomass, around 8.3 megagram per hectare. The best growth and yield of maize, equal to 8.97 ton per hectare, was resulted from cover crop population density of 500,000 plant per hectare, desiccated either at 28 or 35 days after planting, while the control treatment with our cover crop produced only 7.26 ton per hectare. From this result, we can suggest that mung bean cover crop need to be considered in developing a sustainable maize production system in semi-arid area. Finally, I would like to acknowledge Universitas Mataram for funding this research. Thank you.